In the third lesson, we're going to do what's called modeling data. If you think about the first two lessons, we were given an equation of a line, very clearly outlined what that graph would look like. What we're going to do in this lesson is talk about, well, if we're given some points, what would be the line that would best represent those points, and how could we make conclusions based on that? So a scatter plot you've seen before, that's where there's some dots that represent some sort of a relationship. Okay, and what we're going to do is try to figure out what is the line that best suits that scatter plot. Sometimes it's going to be a line of best fit. You've probably seen that before. But sometimes it's going to be a regression function. This is actually possibly a curve that fits those data on those points. Okay, now it says that it finds these lines through statistical analysis of the data. The calculator can do that for us. Okay, and then once we have those lines of best fit, we can make interpolation or extrapolation, in other words, estimating based on the graph that we're given. Okay, so here's an example of a scatter plot. All right, and in this graph, you have your mark on your class and how many absences. And generally speaking, you can see that there is sort of a trend here. This would be what the line of best fit might look like here. And what this means is the higher your mark, the fewer times you're absent. Okay, so in this case, as we go this way, as the marks get higher, absences go lower. Okay, so let's look at an example here. The old-fashioned way, or the maybe grade 7, 8, 9 way, maybe in science, you used a ruler. So you would plot these points and you would use a clear ruler to help you draw a line of best fit. Remember, the line of best fit is supposed to best represent this data. It's not trying to go through each of these points. You can't do that. We're trying to say, generally speaking, what's the pattern here? You know, is the pattern something like this? And when you make that line of best fit, the number of points above and the number of points below should generally be about the same. The line should look like it represents the data. All right, you wouldn't do something where you try to go, you know, let's try to do something like this. It's supposed to be a straight line going through as many points as possible with sort of the same number of points above and beyond. Okay, if we did this and we did a quick count here, we got 1, 2, 3, 4, 5, 6, 7, 8 points below, and maybe 1, 2, 3, 4, 5, 6, maybe 6 points above, and then a few on the line. So that's pretty close. Okay, so then once we have the line of best fit, we can make some predictions. Okay, so it says estimate the slope and the y-intercept. Well, the y-intercept's pretty easy to find. We can just go right here and we can say, yeah, looks like it's about 53, maybe a little bit below 55. The slope is a little harder. Remember, the slope is rise over run. So to do this, maybe what we'll do is we'll pick 2 points and we'll do y2 minus y1 over x2 minus x1. Okay, so I don't know, let's pick, say, a point right about here and say a point right about here. This point looks like it's 560. Yeah, maybe that's not the best one to pick. Let's pick one that looks a little bit easier to work with. Oh, maybe this point, it looks pretty good. This point is the point 1070. Okay, so if we took the 2 y values, 70 take away 60, and we took the 2 x values, 10 take away 5, we get 10 over 5, and so the slope is 2. And what this means is for every hour of study, your test scores will go up 2 marks. Okay? So that's doing it by hand. We're not going to do that very often. Instead, we're going to be using the calculator to figure out our equation. Okay, let's do a little bit of estimating now. If your mark on the first test is 60%, what is your expected mark on the second test? So here's 60 on the first test. Let's predict what would our mark be on the second test. This looks like it's approximately 63%. Okay. So is this interpolation or extrapolation? This is interpolation because it's within existing data. Okay, if you look, there's data here. If we were extrapolating, that would be way over here, past the data. But this is within existing data. Okay, let's try an extrapolating question. So here it says if you have 35 years of experience, here's 35. Let's draw that. Where would that cross the line? Looks like it's about here. You should use a ruler if you were doing this. Okay, and if we connect that, that looks like your income would be approximately 71. I'm assuming that's 71,000. Doesn't say that on the graph, so we'll just leave it as 71. Okay, this is called extrapolation because it's past all the existing data. Okay, so that's doing it by hand. Let's now look at how to do it with a calculator. And I'll admit this is pretty tricky. There are a lot of keystrokes here. I think you should probably make yourself some notes on your cheat sheet so that this becomes something that's a little bit easier to do. Okay, so to do that, first of all, you're going to press Stat. Let me clear the history here so you can see it a little bit easier. Okay, we'll start by pressing Stat. Okay, this pulls up this screen, and if we want to change something in our spreadsheet or our to put in some data for scatter plots, we're going to press Edit. And so this gives me some columns, and we could, for example, put in a bunch of values down one column, and then we could go to the second column and put in a bunch of other data. Okay, so there's, let's make it 90. We have to make sure they're the same. You can't have information in one column and then not in the other column. So let's go like this. We'll put a 5 there. Okay, so now we've got some data. Actually, that 78 is going to end up being weird. So let's put just a 7 there. Okay, and maybe we'll put a 10 here just so it looks nice for now. Okay. So that's how you would fill in the list. And by the way, if there was something on this list that you didn't want, you could go clear list. So that would again be, we'd go Stat, and we would go to clear list, which is 4. And then let's say you wanted to clear that second list. Okay, so look for where L2 is. That's the number 2, so we'll go second 2, and if I press Enter, now I go look at that list. Now L2 is blank. Okay, so now I can put down what I wanted in the first place. Okay, there. All right, so I've got my data entered. That's here. And then I want to know how to graph it. Okay, how do I make a scatter plot? So to do this, we're going to go to y equals for a second. Let's just clear that because you don't want that to interfere. Okay, and now we're going to go up to the plot, and we're going to actually turn that on. And you could turn it on here, but if you go to second y equals, we'll turn this first one on. Okay, so I'm going to press Enter. This is my plot 1. I want to turn it on. Okay, and we're almost always going to be on this flashing icon there. That's for a scatter plot. And you can see here I have L1 and L2. That's where I have my data filled in. That's how to fill out the data so that you can, or fill out the calculator so you can plot it. And now we're going to go to Zoom. Remember what Zoom 6 was if we were graphing a regular graph. But now we're going to go to Zoom 9, which is, it zooms in to fit the scatter plot you've just entered. Okay, so there we have it. That's what the graph would look like. And in this case, you can see it's pretty obvious. It's a straight line. Okay, so after we've done that, now we want to figure out what is the equation of this line. Okay, so let's go over here. This graphs the scatter plot. That's this one here. Now let's go to, if we want to make the equation. If we want to figure out what is the equation, the line of best fit. Okay, so we're going to go to Stat, but instead of pressing Edit, we're going to scroll over there to Calc, and you can see there's a whole bunch of things here. Okay, look at number 4. That's a linear regression, so that's a line. Number 5 would be quadratic, that would be the parabola, and number 6, that would be the cubic regression. In this case, you can see that it's a line, so I'm going to press 4. Okay, so it says linear regression, and now what do I want to make this equation from? Well, I want to go L1, comma, L2. Okay, and now if I press it, it gives me a linear regression, but it doesn't give it to me kind of the way I want to see it. So in this case, it says A is 1, now we use M, and B is 8. So that would give you the equation y equals 1x plus 8. Okay? Now, I want to graph that line. I want the line to show up on the scatter plot. Okay, so now I'll go down here. Now I want to graph the line, and I'm going to put the regression. Okay, so how do I do that? I go to y equals, make sure it's blank, it is. Okay, then I'm going to, now this is where it gets a little confusing because it doesn't really make sense what we're doing. Okay, it says we're going to press vars, okay, and then we're going to statistics, so number 5. All right, and then we want to go to equation. So you have to scroll over here to the equation, and you can see it says regression equation. So we'll press enter. So what it just did there is it took the equation I had on my screen and entered it into y equals, and now when I graph, it's going to show that line on the scatter plot. Okay, so I think we probably need some practice doing that. Here's our practice. We're going to enter this into L1 and L2. Okay, now this is probably not critical, but if I start entering this in my x-axis, that means I'm going to start at 1996. Maybe you want to start here and say this is 6. Then this would be 8, 9, 12, 13, 14, 17, 18, 19. I think we can probably do that just to kind of adjust what is going to be our scale. We can try doing both, but that's just my suggestion. Okay, so let's see if we can do this. So first of all, let's clear this. Let's go to Stat, Edit. I want to clear these two lists, so remember how to do that. I'm going to Stat, Clear List. And what do I want to clear? I want to clear L1 and I want to clear L2. Okay, so I've now got them cleared. Let's enter what I've got. 6, 8, 9, 12. Okay, this is going to be a little tricky for me to be able to see everything. 13, 14, and then 17, 18, 19. Okay. Now I'm going to put the next column in, 78.04. Whoops, got a little trouble here. Okay, so it's entered into our scatter plot. Let's go to make sure that it's turned on. Everything is still the way it should be, so we should be able to go to zoom 9, and there's our scatter plot. Okay, does it ask us to draw this? Use technology to create a scatter plot. Yeah, it says to draw it, so let's just do a quick sketch here. Okay, we have the year down here, and we have distance here. Okay, and looking at our graph, let's just do a quick, so it looks something like that. Okay, let's determine the line of best fit now. So do you think this represents a line, a parabola, or a cubic? To me, I think it looks like it's going to be a line. So let's go to Stat Calc. We're going to pick linear regression, and we're going to tell it we want it to have L1 and L2. Okay, so there's our equation. Okay, let's write it down. Y equals 0.85 848 x plus 72.643. Something like that. I think we could probably do a little rounding off there, so I'm gonna write 0.86x plus 72.64. This is our regression equation. Okay, now it says, let's use that to interpolate a possible world record distance for the year 2006. Okay, so how are we going to do that? Well, first of all, let's go and put this on our graph. If you remember how to do that, we're going to go vars, okay, statistics, equation, regression equation. Uh-oh, that's not where we wanted it. We wanted to go to y equals, right? So let's put it there. Vars, 5, equation, enter. There it is. All right, and now if I graph, I have what looks like the line of best fit. Okay, now it says interpolate a possible world record distance for the year 2006. Well, where is 2006? 2006 is right here, somewhere in here. What is going to be our value right there? Okay, well, we could do this a couple of ways. We could use the formula first of all. So you could go y equals 0.86 times 2006 plus 72.64. This is using our equation and saying x is 2006. Okay, so that works. We'll put that in the calculator. We could figure that out. There's another way we can do this. Now that we have a regression equation, if we go to second trace, and remember, number 1 was to find the y-intercept. It allows us to pick what we want for x. Okay, so looking here, what would we say our x value is if we want to go for 2006? That looks like I'm going to use a value of 17. Okay, you could see 15 and 16 would go there. So I'm going to go here and I'm going to say, tell me what it is when x is 16. And it says that the time would be 86. What is that? Oh, sorry, it's the distance. It would be 86.4. Okay, so y would be 86.4. By the way, that's going to be the exact same answer you would get if you actually did it this way. Okay, so if you want to make yourself a little note here, we're going to go second trace, then we're going to press value, and we're going to go x is 16. Okay. Compare your estimate to the actual world record distance of 85.99. Well, we're a little bit off, but it's close. Okay. Let's try the next example. So Matt buys t-shirts for a company that prints art on t-shirts and then resells them. When buying the t-shirts, the price Matt must pay is related to the size of the order. Now, typically, the more shirts you buy, the cheaper it's going to be, and you can see here that's true. You know, the higher the number of shirts, the less the cost per shirt is. Okay. 5 of Matt's past orders are listed. Matt has misplaced the information from his supplier about price discounts on bulk orders. He would like to get a price per shirt of $150. Okay, so what we're going to be thinking about here is how many shirts do you think he's going to have to order if he wants this price? So what we're going to do is use the calculator to see if we can figure that out. So I'm going to pause it here for a bit for you to try this. What you need to do is enter this data, graph it, and then you find the line or the regression equation. Okay, so use technology. I found this to be the equation. And what does this equation mean? Well, the slope is negative 0.0065. So this means for every additional shirt you buy, the price is going to go down $0.0065, which, I mean, if you wanted to change that to cents, would be 0.65 cents. Still not a full cent per shirt, but that's how much it's going to go down. Okay, and then the Y-intercept is 6.5. So just so you understand what that means, the graph starts at 6.5 and it's going down in price. Okay, this 6.5 means if you order 0 shirts, so initially the price of a shirt is $6.50. And you should write it as a cost like that. Okay, that's what the cost would be if you had 0 shirts. Now, part C, it says, let's extrapolate. Okay, so I'm going to go over here. This is what the graph looks like. What I'm going to do is go here to value and say, when is it going to be $1.50? Okay. So why doesn't this work? Why does it say invalid? Well, we weren't figuring out when X was 150. We're being asked when Y is 150, right? It's the shirts start. So let's go here. The shirts start at 650. We're looking for when is the shirt going to cost $1.50. What is the X value? The X value we don't know. So you can't put 150 in there. We have to do something else. All right, let's try tracing it. Tracing gives us a little cursor that's on the screen, and we can kind of move it back and forth until maybe we can hit Y as 150 on here. So let's try. So I'm going to go down here, and it keeps going, keeps going, keeps going, and I want to go down to 150. Now you can see that going back and forth, I can't quite hit 150. Now you could spend a bunch of time trying to zoom in, get a little closer, but I'm going to say 151 or 152 is pretty close. Okay, I'm going to say, well, maybe I should have just a few less than 766. So right now I'm thinking 766. Let's just go and put here on value. Let's put 766 and see what that gives me. Okay, that gives me $1.52. So maybe I'll go, let's try just 760. What if I put 760 in? Well, that's going to cost me more, so then let's try to go 755. So I'm just kind of playing around with my values here till I get to 150. Okay. Again, what did I do here? I'm looking at this until I can get to 150. Okay, so 766, that's still a little bit too high. Should I try 780? Okay, that's not good enough. So 768. That's pretty close. 769. That's pretty close. Let's say 769 shirts. Okay, so you're going to play around with it to try to figure out what your answer is. For homework, you can do page 24 to 26 in the notes. That's the next couple of pages, so just take a look at the next 3 pages.